Please open in your learning workbook to page 157 and read along. You might have noticed that in the previous problems, we only completed steps 1 through 4. Here are some problems that use all 6 steps. But before we begin, I'd like to share some information with you. What is the purpose of variation? Why do we learn it? Well, variation is very important, and the reason why is because when we observe how quantities are related to each other in one situation, variation allows us to predict how those quantities will be related to each other in a new but similar situation. Here's an example problem that illustrates that idea. The amount of allergy medicine that a physician prescribes for a child varies directly as the weight of the child. Clinical research suggests that 13.5 milligrams of the drug should be given for a 30-pound child. How much should be given to a 50-pound child? Okay, we're going to go through the same steps that we did before, only this time we're going to also do steps 5 and 6. Okay, step 1 says, determine what's doing the varying. Now, the interesting thing about this particular problem is there are no variables in the problem statement, which means we need to come up with variables to be able to write our equation. So here's what we're going to assume. When it says the amount of allergy medicine, we're going to call that A. And when it says the weight of the child, we're going to call that W. Okay, now we go through the steps together. Step 1, what's doing the varying? Well, it says the amount of allergy medicine varies directly. So what that tells me is that A varies. A varies. So I need to start my equation with A equals. Okay, then I have K in the numerator of a fraction. Next step is to look for the LY word. Well, in this problem, the LY word is directly. So the stuff is going to go directly next to the K. And in this case, the stuff is the variable W. So the W goes up here with the K where it's being multiplied. Step 4, if you still have an empty denominator, put a 1 there, and then simplify. So we get A equals KW. Notice that anything divided by 1 is itself, and I dropped the multiplication dot. Okay, great. So this is what we have at the end of step 4, but now we're going to proceed on and we're going to do step 5. Step 5 says, the problem gives us enough information to replace the A and the W with numbers so that we can solve for K. Here's the sentence that contains that. Clinical research suggests that 13.5 milligrams of the drug should be given for a 30-pound child. Okay, so 13.5 milligrams of the drug, that is an amount, so that is a value of the variable A. So the 13.5 is going to go over here. Equals K times. And then W, the weight of the child, is 30. So now I know that 13.5 equals K times 30, and I can solve this equation for K. All right, let's do that. So 13.5 equals 30K. Now be very careful here. The variable K is on the right side. So we're going to divide both sides by 30, not 13.5. Divide by 30, divide by 30, and we get K equals, probably going to pick up our calculators for this one. Let's see what we get. Okay, 13.5 divided by 30 equals 0.45. Okay, we have now solved for K, and we can put that into our equation. So now we're going to get A is equal to 0.45K. Excuse me, I apologize. A is equal to 0.45 W. We're replacing the K with 0.45. Now you might be thinking to yourself, why don't we also replace the A and the W? We have numbers for those. And the answer to that question is, we're trying to create an equation that allows us to predict the future. For any amount A that we have in the future, we can plug into this equation and find the weight of the child that should receive the dosage of that amount. Or, for any value of W in the future, for any weight of child in the future, we can replace W with a number and it will tell us how much allergy medication a child of that weight should receive. Okay. Said more succinctly, if someone tells us A, we can find W, and if someone tells us W, we can find A. This brings us to part A. How much should be given to a 50-pound child? Well, 50 pounds is the weight. So that's telling me that W equals 50. So if I want to know how much allergy medication I should give to a 50-pound child, that just means that I have to replace the W in my equation with 50. Okay, so we're going to go ahead and do the multiplication here. I will once again pick up my calculator. 0.45 times 50 is 22.5. 22.5 milligrams. So, how much allergy medication should be given to a 50-pound child? 22.5 milligrams. All right, let's move on to part B of this question. I'm going to erase everything except for our model. Here's our model. Okay, part B. A nurse wants to double check the dosage on a doctor's order of 18 milligrams for a child of what weight is this dosage appropriate? Okay, here we go. So, in this problem, we are given 18 milligrams, and we're told that that is a dosage. So that must be A, the amount of medicine. So we're told A equals 18, and we're going to plug that into our equation. So we get 18 equals 0.45 W. Now we can solve for W, which will tell us the weight of the child. All right, so we'll divide by 0.45 on both sides. Again, notice that I'm dividing by the number on the right because that's the number next to the variable. All right, 18 divided by 0.45 is 40. So 40 equals W. So now we can answer the question. For a child of what weight is this dosage appropriate? This dosage is for a 40-pound child.